We are continuing to talk about guitars, and there's a few things that are so obvious that I keep forgetting to mention them. I mentioned them in the video. Well, I didn't mention them in the video because I think they're just really obvious facts. Obvious facts about string instruments, and you can pick up a guitar, you can pick up a violin, you can look at any of these things. They have tuning pegs. And you can see that, that's just really obvious. You've got a tuning peg, and if you turn it one way, you're increasing the tension in the string, and that's going to make the tone that the string makes go up. And if you lower the tension in the string, that decreases the pitch. And that's all because if we look at V equals square root of T over mu, and it also equals lambda F, well, we're not changing the string, so mu is constant for string, and then lambda is constant for instrument. So you see that if you increase the tension, if that's a constant, if mu is a constant and lambda is a constant, then if you increase the tension, the frequency goes up. If you decrease the tension, the frequency goes down. Okay, and then the other obvious fact, so that's fact 1. Fact 2 is and this is how you play stringed instruments, is you place your fingers on the fingerboard, and as you make the string shorter, you increase the frequency, so you make a higher note. And again, we're going to look in that case, T is constant, mu is constant, and so then you just get, so that means that V is constant, so as I decrease lambda, I increase F. Okay, and then there's all kinds of other things. Then there's these are not obvious facts, but there's like bending and vibrato, which is basically these are not basic facts about string instruments, and I'm sure there's some other things in there, but if you can make really short, fast changes to the tension and or length, then you can affect the pitch that that it has. Okay, so then I want to talk about harmonics on a string. And basically we're going to have the same string looked at three different ways. So here's my guitar string, and what I said was, in my fundamental, this is my fundamental, and I'm going to say L equals 1/2 lambda. So lambda is the wavelength, L is the length of the string. And then I found that if I made a node right in the center, I could get my first overtone . So I'm going to say, let's see, that's going to be first harmonic. So then I got first overtone, which is my second harmonic. And so here, my lambda equals, my L equals lambda, and I'm going to put right here 2/2 lambda. So my L is 2/2 lambda. Now, my third harmonic, let's put it right like there. My third harmonic went like this, where I broke it into thirds. And so now this is my second overtone, and this is my third harmonic. And so I get L equals 3/2 lambda. So in looking at how waves on a string, when I look at my guitar, it's got basically a whole bunch of, it's got a whole harmonic series on the guitar. And so I can put different standing waves on that guitar, and the note that you hear is a blend of all those standing waves. And at the fundamental, I've got the string going back and forth, back and forth, back and forth. And so in that case, however long this is, that's half of my wave, that's half a wavelength, 2/2 of a wavelength, 3/2 of a wavelength, and then we go on to 4/2, 5/2, 6/2. And so my harmonic series is basically given by L equals n/2 lambda. And that's the harmonic series for a string that's fixed at both ends. Okay, I think that's all I'm going to say about strings, and then I think I'm going to come back and talk about pipes closed at one end in the next video.